Welcome back to Code Meets World. Today we're going to be looking at LeetCode problem number 238, which is product of array except self. So in this problem, we're given an integer array nums, and we need to return an array answer such that answer I is equal to the product of all the elements of nums except the number in that position. Then we're told that the product of any prefix or suffix is guaranteed to fit in a 32-bit integer, and the algorithm must run an O of n time, and we can't use the division operation. So let's see what this is telling us. So this is saying that if we're given the input of 1, 2, 3, 4, the output is going to be an array of the same length, where each element in output is equal to the product of every element in input except for the element in that position. Right, so for this first element, this is the product of every number except the 1. So it's just the product of these three. 2 times 3 times 4 is 24. To get the 12, we ignore the 2. So we just multiply 1, 3, and 4, and we get 12. Same for 8, we ignore this one, multiply the others, and for 6, we ignore this one and multiply those first 3. So here I've drawn the input array that we're given in the example, which is 1, 2, 3, 4. And let's talk through how this would work intuitively. So the way I described when I went over the problem in the write-up is that all we really need to do is say, let's create a solution array. We can call that solution. And for each value to compute it, we simply need to take the number in that position and ignore that one, and then just multiply together the other 3. So 2 times 3 is 6, times 4 is 24. So this first value would be 24. We would do the same with the next one, ignore the 2 and multiply 1, 3, and 4, which gives us 12. We would do the same, ignore the 3, multiply these, and that would give us 4 times 2, which is 8. And finally, we would multiply the first 3 together, ignoring the 4, to get 6. Now, this makes sense, and this produces the right result, and it's pretty intuitive, but the problem is that in the write-up, it said that we have to do something in O of n time. You might notice that this is not O of n time, because for each value, so for each of n values in this input array, we have to ignore it, and then go and iterate over the other n minus 1 values. So for each value n, we need to do n minus 1 extra computations. So unfortunately, that means that this algorithm is O of n squared. And since we need O of n, we can't use this method. So the secret actually lies in the wording of the question, where it says, the product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. So let's explore what that means. So I've emptied the solution array, and we're going to talk about a different way that we could go about solving this problem using what's known as prefixes and suffixes. So if we look at the input array, we can say that if we choose any number, so for instance this 2, the prefix to 2 is any number to the left of it, so in this case the 1, and the suffix of 2 is any numbers to the right of it, so in this case 3 and 4. If we multiply the prefix, which is 1, times the suffix, which is 3 times 4 or 12, we get 1 times 12, which equals 12. And if you remember in our solution, I'll actually write it back in so it's easy to see. 12 was the correct solution for that case. And so we could do the same thing for anything else. If we wanted to do 3, to find the solution, we just have to multiply the prefix, which is 1 and 2, so 2, times the suffix, which is 4, and that gives us 8, which is also correct. So this solution has the potential to be better than O of n squared, because we can loop through this input array one time going forwards, and a second time going backwards. And when we do that, we can compute a prefix and a suffix array, which just holds the values of all of the prefixes of every element in the array, and then all of the suffixes of every element in the array. And then like I did here, we can just take everything in the prefix array times everything in the suffix array, and that'll give us our solution. So here I've rewritten the problem so that we can try it again using this different method of prefixes and suffixes. So the first thing we need to do is I've created these two empty prefix and suffix arrays, and what each of them is going to hold is for every value in the prefix array, it's going to hold the product of all of the values that precede whatever value this represents in the input. So this first value here needs to represent the product of all values that appear before this one. Well, nothing appears before the 1. So we're just going to make the prefix a 1 in this case. Then what do we do next? We need to look at the next value in the input array, and the prefix for this is going to be the product of all the values that come before this too. In that case, this is just the 1, so the product of all of those values is just 1. Next, we'll look at 3. And the prefix for 3 is going to be the product of all the values before 3. So 1 times 2, which gives us 2. And finally, 4 is to calculate the prefix of 4, we just need to do the product of all the values that come before it, which is 3 times 2 times 1, or 6. So that's our prefix array. For the suffix array, we're going to do the same exact thing, but looping backwards through the input list. So we'll start at the end here at 4, and the suffix is going to be all the values that come to the right of 4. And because there aren't any, just like we did for the prefix, we'll just make this 1. And then next, the suffix of 3 will be everything to the right of it, the product of everything to the right of it, so that's just 4. So we'll write in a 4. The suffix of this position will be 3 times 4, which is 12. And finally, the suffix of 1 will be everything to the right of that, which is 24. And if you notice, like I said from the start, if we take the prefix and suffix of any position and multiply them together, we should get our solution. So here we just multiply together 1 times 24, which gives 24, 1 times 12, which is 12, 2 times 4, which is 8, and 6 times 1, which is 6. And this right here is the final solution that we want. So it works. And the reason that this solution is better than the original one is it's n. It's not n squared. And you might be asking, but we loop over the input array so many times, and that's true, but we only do it once to go through and compute the prefix array. We go back again to compute the suffix array, and then we go through one more time to do the multiplication and solve the problem. So that would mean we're going O of 3n, because we go through it 3 times. But as you might know from studying big O notation, that you can remove any of the integer constants. So this is just O of n, which makes it an order of magnitude faster than the n squared solution. So the first thing we'll do in the code is create the prefix and suffix arrays. So I can call those pre, and I'll set that equal to an array of zeros, and I will multiply that times the length of nums. And I'm going to use the length of nums so many times, I should probably make a variable for that too. So I can say n equals the length of nums, and then say that this is going to be 0 times n. For the suffix, which I'll call suff, I will set that equal to basically the same thing, 0, and I'll take that n times. And this is just going to make an array that's filled with n zeros. And the reason I'm doing that instead of an empty array is because that'll make it easier to go backwards to create the suffix, which we'll talk about in a second. So then, like I mentioned on the whiteboard, the first element in prefix and the last element in suffix are always going to be 1 because nothing comes before the first or after the last value. So I'm going to go ahead and account for that right now by saying pre0 equals 1 and suff, this will be n minus 1, also equals 1. Next, what I need to do is go through all the values in nums, because remember, I have to go through 3 times. Once to compute the prefix, once to compute the suffix, and then a third time to do the multiplication. So the first time we'll go through it, I'll make a comment here, and I will say prefix. So we can say for I in range, I guess I can just say n here. So for each index in range n, what we need to say is prefix of, actually, I guess I want to start at 1 and increment, right? Because I don't want to start at the first value because I've already added the first value. So I think I actually want to go and start at 1 and work my way up to n. So then what I can say is prefix at I equals prefix, so pre at I minus 1 times whatever nums I minus 1 is. Now, if this is confusing, remember what we talked about on the whiteboard. So again, this first one I've already added. I've already added that to be 1 every single time. But then what we want to do to get the next value is we want to take whatever this previous value was, because remember, the prefix is going to increase each time because we're adding everything together in the array. So we'll take whatever we saw before this times the value in nums that we're on next. So 1 times 1 is just 1. So this just ends up being 1. But to get this value here, we need to multiply together the previous value in prefix times the associated value in the input. Because remember, we're multiplying together all of these values to get this. And then to get this last one, which is 6 here, we take the previous value, which is 2, times the associated value in the input. Because again, to get this, we need to multiply all of these together. So we would multiply everything we've seen so far times the most recent one, which gives us 6. So that's why this would be, to get I, we need to multiply the previous value times whatever number we're seeing in the input array. So hopefully that makes sense. Then we can compute the suffix in much the same way by saying for I in range. Now, this one is slightly different because we have to start at the end and iterate back towards the start, but we need to skip this very last one because remember that one we already filled in is 1. So we'll start at n minus 2. Usually when you loop backwards, you start at n minus 1, but we're going to move to the left. This would be n minus 1, but we're going to move to here since we already added the 1. So n minus 2, and we will subtract 1 until we get to -1 exclusive. So it'll stop at index 0. And this time we will say suff I equals suff, in this case it's I plus 1 instead of minus 1, because whereas up here we needed to look backwards, here we actually need to look to the right. So we need to add 1 to the index we're looking at. So that would be suff I plus 1 times nums I plus 1, like that. Once we have both of these, we're pretty much done because now we just have to compute this multiplication. So we have to go through n, the length n, one more time. So I will say here product. So we can say solution is the empty array. And then we can say for I in range, this can just be n this time. So I in range n. And then we can say solution.append. And this would be pre, so the prefix at I times the suffix at I. And then we could just return whatever solution is. So let's run this and see if we have any errors. Oh, I see one already. This needs to be a comma and not a period. So let's fix that. And we are passing both of the test cases there. So I'll go ahead and submit. And yeah, that's worked. So this is right in the mix for about the runtime that we would want here. I'm pretty sure we could probably make this even better by, instead of looping 3 times, maybe we would only have to loop twice to get the prefix and suffix. And maybe we could just store the product of the two of them as we go, instead of doing a 3rd step to compute the product. But I like the readability of this, and overall it's a pretty good solution. So thank you so much. Let me know in the comments if you have any questions, and I will see you in the next video.